Let's look at some applications involving percents. Problem number 1, a study finds that 750 people out of 1,280 surveyed support a particular ballot measure. Determine the percentage of people in the survey who support this measure. To calculate a percent, generally the rule of thumb is going to be to take the part of the group that we're interested in and divide by the total. And I'm using a fraction bar just to denote divide. If we think about that here, the part and the total are given to us. There are 750 people out of 1,280 surveyed. There are 1,280 surveyed, that would be the total surveyed. And then this is the part, 750 people that we're interested in because those people support the particular ballot measure, and that's what the percent is that we're trying to find of. So we would take 750 and we would divide it by 1,280. Now, if you think about that fraction we've just created, that should look a little bit similar to when we first defined percents. Remember, we looked at 25%, and when we defined that, we said 25% is 25 over 100. Here's this fraction, and we can take any fraction and make it into a decimal, and we made this originally into the decimal of 0.25. Now, our goal is not to have an answer that's a decimal. Our goal is to have an answer that is a percent. So we can start with this fraction, go to the decimal, and then use our quick trick of moving the decimal point to go to the percent. Here we have a fraction. To make it into a decimal, 750 divided by 1,280, just throw that into your calculator, and you will get a decimal that goes all the way across your calculator. At least that's what happens in mine. So I'm going to use an approximate because if it goes all the way across, generally that means that the calculator the decimal keeps going and the calculator just clips it off at the end of its screen. So we get, at least in mine, I get 0.5859375. Okay, so that's the decimal equivalent of that fraction, 750 over 1,280. What we want, again, is the percentage of people. So I need to move the decimal point from where it's located 2 places to the right to make it into a percent. So this would be 58.59375%. Now, generally, we don't want to write all those digits out. I'm writing it out just to kind of explain what I'm seeing in my calculator. But generally, we're going to round. And with this percent, if it were me, I'd probably round to the first decimal point, but it really depends on what you're asked to do. Now, the first decimal point, or place, would be 1 digit past the decimal place. So that would be at the 5. Now, to round at that first decimal place, we're always going to look 1 digit beyond. So we're going to look at the 9. So if I were trying to round this, I would look at the 9, and the rounding rule is if the number and that 9 location is a 5 or better, we're going to round up. We're going to round that 5 that I had prior to that line I drew, so where I'm rounding, we're going to round that up. So this would become 58.6 because the 9 makes this closer to the 6 than it does to the 5. So 58.6% of people support the ballot measure. I should say those are the people who are surveyed. Now, I chose to round at the first decimal point, but you may have a problem in your homework that asks you to round at a different place. So let me just give an example. If I had been asked to round at, say, the second decimal place, I use a different color here, let's say 2 decimal places in. So if I had been asked to round at 2 places after the digit, 58.59, what I would look at, again, is the number that comes after that boundary line, the 3. Now, the 3 is below a 5, so when I go to round this, I wouldn't change the 9 that comes at the end. I would keep this at 58.59%. So the 3 makes the 5 stay, or the 59 stay a 59. It doesn't change it to 60. Okay, so it depends on where you're asked to round to. If you need a little review of rounding rules, I'll have something in D12 for you to check on, but that's just a quick review of rounding. Before I move on to the second problem, I did want to mention it's always good to check your answer, at least check to see if it makes sense logically. If you think about 750 out of a total of 1,280, 750 is more than half of 1280. So our answer, we can anticipate it has to be more than 50%, because 50% would be half. So if you look at our answer, we do get more than 50%. So that is a rough check, and a really rough check using should it be less than 50% or more than 50%? We know that 750 is more than half of the people surveyed, so it makes sense that our answer is more than 50%. Now, it's not most of them, so it's not going to be close to 100%. It's just above, more than a little bit more than half, so that's why the 58.6% makes sense. All right, moving on to problem number 2. In a biology class of 48 students, 15 of them have full-time jobs. What percentage of these biology students have full-time jobs? Well, remember the rule is for calculating a percent to take the part and divide by the total. Looking at these numbers one by one, 48 students, that's the whole class. So that would be the total. So that would be what we divide by. 15 is part of the class that have full-time jobs. So it would be 15 divided by 48. When I throw it in my calculator, I get a number that doesn't go all the way across. It ends up being just 3125. I left off 0.3125. My decimal was there. I wrote it but didn't say it the first time. That's my decimal value for 15 over 48. So then I would move the decimal point 2 places to create, again, the percent, which is what I want. So I'm going to have 31.25% of students in that biology class have full-time jobs. Once again, doing a really rough check, 15 is well below half of 48. So half of 48 would be 24. So 15 is definitely well below 50%. So it makes sense that we're getting something that's quite a bit below 50% for our answer. Problem 3, a college reports that 72% of its fall term students drive to campus. There are 2,400 fall term students. How many drive to campus? All right, so this one's a little different. We're given the percent and we're asked, how many is that? Okay, so one tip, when you're asked to calculate a percentage of something, in this case, percentage of fall term students, what we are looking at in mathematics is that this of is often considered multiplication. It's another word for multiplication. So the of there that comes after a percent means to multiply. So when we see 72% of fall term students, I'm going to abbreviate to fall students here. What this is saying is multiply 72% and the number of fall students. So that of means times. So let's go ahead and write that out. Now, one thing to note about percents is you never want to calculate directly with a percent. You always need to make it into a decimal. That's why it's so important to be comfortable going back and forth from decimal to the percents. So I'm going to take this 72% and convert it to the decimal. So this is going to be 0.72, and I'm going to multiply that by the number of fall term students, which was 2,400. When I do that, doing that calculation, I get 1,728. That would be 1,728 students who drive to campus. Again, a quick check using that 50% rule I was talking about. 72% is more than half, right? It's more than, well over 50%. So I need to have well over half of this student body. So I've got 2,400 students. Half of that would be 1,200. And you can see my final answer of 1,728 is well over 1,200. So that's kind of making sense with this quick 50% rule. Problem number 4, a store advertises that a dress is on sale for 35% off the listed price. If the list price of the dress is $57.60, what is the new price of the dress? Well, first off, 35% off means that we are going to be able to reduce the price of the dress, right? It's off means reduce. So we need to figure out how much that is. So there's kind of two steps here. We need to figure out how much we're reducing the price by and then work at figuring out the new price. So let's start with working out what the reduction is. So the reduction is 35% of the current price. Remember how I said of means multiply. So 35% would be 0.35. We always want to make it into a decimal to do calculations with percents. 0.35 times the price of the dress, $57.60. So if I do that calculation, 0.35 times $57.60, I get a reduction of $20.16. So this is the reduction. Okay, that is not the new price of the dress. That's how much the dress is reduced by. So to figure out the new price, we would go ahead and take the original price of $57.60 and reduce it by 2016. So subtract 2016 from it. So the new price would be $37.44. So just simply do the subtraction. So the new price paid for the dress would be $37.44. Okay. If we again use the quick rule, 50% rule, 35% means that we're taking off less than half the price. Well, half of 57, you can estimate that as being about, well, if we round that to 58, that would be about $29. And so you can see we're taking off less than $29, right? We're only taking off $20. So this is, again, the rough estimate using the 50% rule makes sense here. Another quick way to do these kind of percentages off of prices is to think about it the following way. Let's say you have 35% off a listed price. That means instead of paying 100% of the price, you are paying 100% minus 35% of the price. Now, 100% minus 35% means you pay 65% of the price. So this is what you would pay. You pay 65% of the price. Now, if I were to do that as a calculation here, I'm going to squeeze it in, that would be 0.65 times the price of $57.60. Squeezing my numbers in here. And if you did that calculation, 0.65 times $57.60, that calculation would actually give you exactly our final answer here. It would give you $37.44. So there's actually two ways you can actually do percentage off in terms of prices. You can either first calculate the reduction and then subtract it from the original price, or you can think about how if you've got 35% off the price, you're really paying 65% of it, and then calculate with the 65%. So there's a few examples of calculating or calculating a percent.